Good day, everyone. My name is Ian Piddock, and I'm Director of Solution Strategy for Product Master Data Management here at Stibo Systems. And it's a pleasure to be here today to talk to you about AI and ML. So what's all the hype about? Pipe dream or real benefits? You decide. And I'm going to be joined here today in this presentation by my colleague Jasper Grode, who I'll hand over to later. So the agenda for this presentation today, I'm going to define AI, then I'm going to look at the benefits of artificial intelligence, the challenges that we're facing today around this and why we need AI, the attribute and data explosion. We're going to take a look at that, what the problem that we're facing in the market is with regards to that massive explosion of data attributes, how we then go about addressing that challenge. Then we're going to look at the AI-powered MDM within the Stibo Systems platform, and then we're going to take a quick look at the roadmap of what we're going to be introducing in the future within the Stibo Systems enterprise platform. Okay, so defining AI. So AI, artificial intelligence, and this is really about incorporating human intelligence into machines. All right, it's as simple as that. It's the ability to get computers to solve problems the same way in which humans do. And that is by looking at past experiences and then applying what we've learned in the past to the situations that might be similar in the future. And AI is what we describe as an all-encompassing term for two other terms that you might be familiar with in the market. And that is terms like machine learning and deep learning, which is ML and DL. And finally, there's two further classifications of AI, and that is general AI and narrow AI. General AI is the sort of artificial intelligence that's built into robots and drones, where they might be on a journey and they have optical sensors to be able to detect when they're approaching buildings or walls, and they can then make a decision on what to do, turn, proximity alerts and those sorts of things. That's more of a general AI that's built into those sorts of devices. But narrow AI is more of a rule-based approach where a desired outcome is defined, and then the computer is then going to learn, the system is then going to learn how to achieve that best desired outcome. And narrow AI is more what I'm going to be talking about today. So let's go down one step and look at machine learning. So as I said, machine learning is a subset of artificial intelligence, and this is about teaching machines to learn like humans based on experiences that we've had in the past. And then once we've recorded those experiences, we're then able to make predictions based on what's been learned. So by having an experience, you then learn what happened during that experience, and then you can then look back at that past experience to make a better decision moving forward. And the way we do this in software is we train algorithms. So we work through a process where you first present a set of data along with the rules and the desired outcome, and then you run that algorithm and then you get results. If you then keep applying more data over and over again and different data, more experience is then gained and a better decision can be made. And the improved decision making is brought about by, it's the same with humans. The more experiences you have and experience of doing things, the better the outcome is going to be and the better the decisions are going to be made in the future. And this is exactly the same with the machine learning algorithms. Is the more data that's passed through, the more experiences are had, the better the decision making is going to be at the end of the process. Deep learning, so this is beyond machine learning, so this goes one step further. This is about working more like the human brain, and this is where we're creating artificial neural networks within code, within software. And this deep learning algorithms are more about cross-referencing. So usually they're used by applying a number of machine learning algorithms together and allowing then the software to be able to cross-reference between the experiences, what's been learned from multiple machine learning algorithms. So then being able to detect characteristics that are common across those different algorithms in order to be able to predict better results. And we do this as humans. Whenever faced with a new situation, our brains, without us knowing, are automatically looking back at similar situations that might have happened in the past that could be comparable to help us make a decision on what to do in this new situation. So some deep learning algorithms that you might be familiar with in the market are used in some of popular accessible services. So Google use deep learning algorithms. I believe that Instagram, along with their photos that are being used there. But also, they're probably the most popular use case that we're all aware of, or maybe not aware of, is that of the use case around Facebook. So a lot of the adverts that appear in a Facebook stream are generated and put into your stream based on machine learning and deep learning algorithms based on your past behavior. So I'm going to work through a narrow AI example here, just to put what I've said into some context. So let's just say this is data that's coming into an organization. And typically, if a human was going to be dealing with this data, you can see we could have some gaps here, is you load it into probably a spreadsheet and you'd analyze it, you read through it, and you then work out by sorting and copying and pasting what the missing values might be. The idea here is that the machine learning algorithm can do this for you. So it's actually replacing that manual task with an automated task. So if you were to present the bottom line of this data here to the algorithm is going to go, how on earth am I supposed to work out what height, width, depth, and these classification codes are? I've got nothing to base these decisions on. But if you train the algorithm by first loading in data in this kind of order, it doesn't have to be this order, but this kind of order, it can then work out what those values are going to be at the end. So if I just work through this, we've got a complete data set at the top. But the second one, we're missing the E-class value. So it's then able to learn from what it's learned on the top line. It then knows that the E-class value is going to be the same based on the information that it's learned already. And then it does the same thing. So based on what it's learned from 800 grams of carrots and 400 grams of carrots, and the existing classification codes that have been put in, it's then easily able to then work out that they're the same classification codes. Then we move to a different type of product, similar but a different packaging. So we've gone from a tin to a bag. So the only thing that's really changed here is the packaging. So the categories are different, but they're complete, so that quickly the algorithm is then able to work out the missing classification code again. And then based on what it's learned with regards to tins and bags and different packaging types and the codes, you can then work out what all the classification codes are in that final step. And it's only when the algorithm has been taught all these things that it's then able to say, okay, I know about the different types of packaging, and I know that a different height, width, and depth, and there's a pattern there that I recognize with regards to height, width, and depth, and I now know what all the classification codes are. I'm now able to accurately predict what the missing values are going to be there. So that's it's a narrow AI example, very simplistic, in order to try to present how these algorithms are working. So the benefits of AI, speed. So we're able to deliver results much, much faster. If we're able to actually remove those manual processing steps, so the human loading data into spreadsheets, sorting and analyzing and filling in the gaps, now we can get a machine learning algorithm to do that for us. Accuracy and consistency, humans can make mistakes, but data with regards to a machine learning algorithm, because it's using the same method over and over again, and it's only creating results based on what it's learned, it's actually going to be more accurate. It's going to, because it's following code, it's going to be more accurate over time. Oh, I beg your pardon. Productivity. So by removing that need to do things manually, you can make humans more productive. So instead of spending time processing data going into spreadsheets, by using machine learning algorithms, we have more time to then get onto more important tasks. Efficiency, that's related to speed. Now we're able to do things a lot quicker and at a lower cost because those manual tasks are being undertaken by a machine learning algorithm. And finally, we have that ability to be able to repurpose employees. And I don't necessarily mean replace them with robots like Terminators or anything like that, but we can actually get humans onto other tasks that are more important, like satisfying customers. So the challenges we're facing today, why are we needing machine learning algorithms to help us with our data processing? Well, there's this data explosion that's gone on. So master data, my master data isn't the same as your master data. We're all managing different sets of master data. Typically, we're managing master data around product, party, location, assets, and so on. But then you have to apply the additions to those. So there's language variants, there's supply chain data, there's different category assignments that have to be applied to that, different contextual attributes with regards to categories and taxonomies. Then there's the retail data standards, there's extra attribution with regards to food service. If you're working in food, you have to be able to provide nutritional values. There's lots of regulatory, legislative and other trading standards that have to be used. And there's also a lot of attribution that's related to B2B, B2C, e-commerce and omnichannel, all different types of attribution. So what does that look like? Well, when we were just managing standard master data according to one type, we were probably working with this number of attributes in order to describe a single product. But then when you add in supply chain, when you then need to be able to move product from one place to another, you then introduce in a lot more attributes that you then have to manage with regards to that same product. And then there's the retail specific attributes, depending on which retailer that you want to sell this product through. You then have to deal with the different types of retail attribution that's necessary. And then, of course, if you're selling food and other products that are bound by standards and regulation, there's another set of attributes that you've got to be managing on a continuous basis. And then there's omnichannel, right? So we've just gone from the in-store model and suddenly we've gone multi-channel. You've got multi-channel, there's lots of different types of channel. And now you have to manage all of those attributes as well. So how do we address this challenge? Well, you could just start using more spreadsheets in order to manage that data. You could use more applications. You could buy new applications to manage different data sets and add them to your existing infrastructure. You can provide more people. You can just throw more bodies at the problem and solve the problem that way. Or you could pass the problem out to someone else. You could pay for a service that's going to be able to help you with this data management process. Or you can go about looking at the systems that you've got and then introducing new types of user experiences and user journeys and different user interfaces in order to make people more efficient. However, there's problems with all of those approaches. So with more spreadsheets means you have less data governance. More applications means there's more integration, there's integrity issues with regards to the integration between those applications. More people, full-time people, it's more cost and more complexity that you're introducing. Outsourcing and offshoring, again, more cost, and then you lose some control. And with more advanced user interfaces, yes, you're going to get more efficiency. But when you're adding more attribution later, you've then got to revisit your user interface again. So what's the alternative? So it's AI-powered MDM. And at this point, I'm going to hand over to my colleague, Jasper Grode, who's going to walk you through how Stibo Systems has applied AI and machine learning to our solutions.
Well, thank you, Ian. Yes, my name is Jasper Grode, and I'm Director of Multi-Domain Master Data Management in Product Strategy with Stibo Systems. I'm also responsible for some of our innovation initiatives as it relates to machine learning and AI. I'm happy that so many of you are listening in to what we have to say and offer here at this conference. So AI-fueled MDM, AI-powered MDM with Stibo Systems enterprise platform STEP, it's actually a two-way street. We're committed to using AI technologies to improve performance in your business as you use our product. And it's a two-way street, really. It's a two-way street in the sense that we build in ML and AI algorithms to improve certain processes for master data management. And we do that by developing our own algorithms as cloud services. We partner with vendors. We embed AI engines within our solutions. And we also connect to third-party software providers within ML, within deep learning, such as Google and Amazon. The other side of the street, you could say, is that you need to fuel your AI and initiatives, AI and ML initiatives with good master data. If you do not have good master data, then you end up fueling bad data to your AI and ML initiatives, and that may lead to wrong conclusions. That will lead to wrong conclusions and incorrect results, hurting your business. So it's two ways. We both provide ML and AI services within our platform and technology, as well as we are a platform for mastering your data to fuel ML and AI initiatives outside of the technology. So let me take you through some of our current AI and ML initiatives that we offer within our technology and in our product. We earlier sort of was a little provocative to say that ML and AI might be a hype, but it's definitely not a hype, and we don't see it that way. It is something real, and we have adopted a number of technologies in our platform to fuel those initiatives. The first one I want to mention is an example where we've integrated with a provider of ML and AI technologies, Google Vision, to allow us to search and categorize images and tag images so that they can use that data can be used for better categorization of your products, better search engine optimization through better image metadata. We can build the metrics that you get back from, or the data that you get back from the Google Vision integration, where we fuel images to Google Vision, and in return we get information back on what this image is all about, what is in this image. That can be used to further improve the quality of your data and make better decisions as you work with your products on the system. In a typical retail scenario, but probably also for other verticals, the problem of multiple images for the same products can be a quite significant challenge, especially as you work with multiple vendors that supply the same products. So with our image deduplication, which is an example of where we build in our own algorithms in the platform and in our technology, we can help you prevent the use of non-compliant variants of your images, of duplicate images, avoid the execution of duplicate workflow approval routines. So basically your business end up saving time working with your images. And the tooling will help you to optimize storage and application performance, keeping costs down simply by helping you remove images that are duplicates of each other. It uses, under the hood, it uses a p-hash algorithm and bit comparison to compare images and help you clear those duplicate images out through a clerical review workflow. In our product data syndication platform, where we are helping manufacturers and retailers alike collaborate in the information supply chain through strong and powerful product data syndication tools and applications, we use prediction to match for attribute mapping, for instance, between master data, source, and channel data. So you're faced with your own set of data, and you need to map that up against data requirements for instance, a retailer. That mapping exercise can be somewhat of a challenge and time-consuming, but using ML and AI, we can then help and speed up that process by making predictions on what are best matches from a source attribute into a target attribute of that channel that you're selling your products in. And we monitor patterns associated with the mapping of measurement systems and currency, and we thereby provide automatic conversion between values that you have in your data set, in your master data, up against legal values in the channel's data standard. An example is mapping, for instance, of color schemes or of metrics, doing a metric conversion. ML-enabled auto classification. Well, The challenge of onboarding items onto your MDM platform and classifying those items is critical in order to achieve a high level of data quality, so that if you classify items correctly, there's a much higher chance that that you have the right set of attribution for those items, and thereby having a good level of data quality as you send that data downstream to consuming systems. But the onboarding process, the classification, can be time consuming, especially as it scales into the number of items that you are onboarding into your business. With ML-enabled auto-classification, we have a trained algorithm in our own cloud microservice architecture, where we build in tooling so that we can train an algorithm to know and understand how your items are typically classified. And then as we bring in, or as you bring in additional items from your manufacturers, from your vendors, the algorithm will help auto-classify your items, and only those items that the algorithm does not have a good confidence in classifying will be put through a manual classification workflow. And we have seen good examples and good test results with this, where up to 90% of onboarded items were automatically classified and classified correctly. So it's something that can remove a large portion of your onboarding efforts. We've also applied cognitive data record deduplication. This is something that is available in our supplier and customer MDM solutions, and it is tooling that will allow you to train an algorithm to know when customer data records, supplier data records are potential duplicates. So in a way, it works in a similar way to our image deduplication, only for customer data records or supplier data records. It reduces future duplicate review task lists by learning from data steward activities. So when two records were not identified as duplicates or were identified as potential duplicates by the algorithm, through a clerical review flow, a data steward will then mark those two records as either yes, they are duplicates, or no, they are not duplicates. And that will then go back into the machine learning algorithm, and thereby it learns from that experience. So that goes back to what Ian said about training machines. They have to learn from experiences. And that experience is something that a human will typically feed back through the actions that the human is taking against the data. Product record match and link is one where we have used a perceptron to speed up the identification of supply-side items in a buy-side, sell-side setup to quicker identify duplicate items on the buy side. It's an example similar to the one I mentioned just before, only for product data records. And it's solved with a plethora of technologies with TensorFlow and Python. And we use step business rules and APIs. So it's actually a configuration more than anything else of leveraging the machine learning capabilities with our technology. The same goes back to the auto classification example I gave before. The configuration of the workflow is done by configuration and business rules, and we simply just call out to the machine learning algorithm to get the feedback. So let me lift the veil a little bit on what we have in store for the future. These are just some examples, and roadmaps may change, but currently what we're looking at is topics around data quality. So for instance, outlier and data anomaly detection. With the data explosion that Ian talked about before, then it's critical that you as a business are able to identify data anomalies in your data so that you can correct it and you can fix that data. Also outlier detection, but similarity search, which is kind of like the flip side of this, at least from a business perspective, is something that is that we're looking at. Simplifying workflows and workflow decisions. So how do we make decisions in a workflow better and based on patterns in historic decisions? If a user continuously does something in the user interface with certain patterns, how do we identify those patterns and then adopt and optimize the workflows that support that user journey so that users are better guided in a user experience? That is something that we're looking at with simplified workflows and workflow automation. Self-integrating systems and self-adopting system interfaces through schema matching. Think about industry standards. Think about how you want to be able to take your own set of data and map that up against an industry standard that you need to support in your business for maybe compliance reasons. Self-integrating systems, having an ability to automatically map schemas across system boundaries is something that could lower IT costs as you implement new technologies. Recommender systems for improved data quality, data valuation, and process optimization is one that we will actively be looking at as well. And we are announcing that we have started or will be starting an industrial research program sponsored by the Innovation Fund Denmark and in collaboration with Aarhus University. In this first phase, it's a 3-year PhD study in collaboration with Aarhus University. And the goals of this is to look at, to research and implement a prototype of a recommender system for better and improved data quality and data governance in master data management. The goals of the project are listed on the slide. They are presented from sort of an academic perspective, and I've tried to highlight some of the essential words in that: algorithms, problems, quality identification, distribution. Human actions, again, how do we use human actions to train a recommender system to help users provide better data quality? Implement an experimental recommender system to validate its usefulness. And then we're also looking very critically at privacy and data regulation as part of this project. So that was it. Ian and I would like to thank you for listening in. It's been a pleasure to be here today, and we will take any questions as they may be posted in the chat. Thank you.